Initially designed to meet the needs established by the U.S. Army for its air mobile assault mission, the Sikorsky Black Hawk helicopter today is expanding its role to perform a variety of specialized missions. The Black Hawk is designed to take off and land with full combat efficiency at altitudes exceeding 4,000 feet and temperatures up to 95 degrees Fahrenheit. Under these conditions, the Black Hawk can take off with its full combat load and climb vertically at more than 400 feet per minute. Also under these conditions, it cruises at 145 knots with an endurance of more than 2.3 hours. Black Hawk is the only operational U.S. military helicopter with rotor blade, engine and windshield de-icing equipment for cold climate operations, and the only one qualified to operate in icing conditions. De-icing effectiveness has been demonstrated in extensive tests. The helicopter's 8,000 pounds capacity cargo hook enables it to efficiently transport vehicles, fuel, ammunition, and a variety of other external loads. In one trip, it can carry a 105mm howitzer, including gun crew and ammunition, or two 750-gallon containers of fuel, or a Gamma Goat vehicle. With 12 helicopters, a Black Hawk unit can reposition an entire 105mm firing battery in one lift. A major U.S. Army design requirement was survival in a high-threat combat environment by avoiding detection and by withstanding enemy fire. The Black Hawk's high maneuverability and control responsiveness allow it to perform extended nap-of-the-earth flying at high speed, making both electronic and visual detection very difficult. At its design weight, the Black Hawk structure can withstand load factors of 3.5 Gs. Nap-of-the-earth flight is greatly enhanced by generous rotor offset and tail rotor thrust, which provide a high level of agility. The Black Hawk main rotor blade employs titanium composite construction, advanced airfoil and twist, and swept tips to improve lift and speed and reduce noise signature. It also is highly survivable, able to withstand completely hits from 7.62mm 30 caliber and 12.7mm 50 caliber rounds, and most single hits from projectiles up to 23mm. The main transmission can operate at full flight power for 65 minutes or longer after being drained of oil. Triply redundant hydraulic and electrical systems add to survivability by permitting mission completion even if both main hydraulic or electrical systems are damaged. Black Hawk is responsive to the stringent crashworthiness objectives of U.S. Military Standard 1290. It is designed for occupant survival in vertical impact crash conditions up to 38 feet per second. High reliability and ease of field maintenance and repair result in high mission availability. Modular design, accessibility of components, and components that are interchangeable right and left reduce maintenance workload and part stockage. Damaged modules can be easily removed and replaced in the field. The aircraft has a 5.1-hour mean time between failures and requires only 1.5 maintenance man-hours per flight hour, which represents a 75% reduction in maintenance requirements over previous helicopters. As many as 6 Black Hawks can easily and quickly be loaded on a C-5, and 2 on a C-141, and 1 on a C-130. The General Electric T-700 engines developed specifically for Black Hawk reduce fuel consumption by about 25% compared to previous engines. The engines feature modular construction for ease of maintenance in the field, and integral air particle separators to avoid engine erosion even in severe sand environments. The technical and operational attributes of the Black Hawk have led to its selection by the U.S. military to fulfill other missions. The U.S. Army has selected it as the new quick-fix special electronic mission aircraft, designated E-860A. For this role, the basic Black Hawk has been modified to accommodate a 1,750-pound electronics package. 4 dipole antennas are mounted on the rear of the fuselage, and a deployable whip antenna is mounted underneath. Its mission is to intercept, monitor, and jam enemy radio communications. The U.S. Navy selected a derivative of the Black Hawk as the air vehicle for its new light airborne multi-purpose system known as LAMPS Mark III. Called the S-860B Seahawk, the aircraft will operate from frigates, destroyers, and cruisers in anti-submarine warfare and anti-ship surveillance and targeting missions. 5 prototypes of the Seahawk had successfully completed the development, ground, and flight test program and sea trials, meeting and in most cases exceeding Navy performance, milestone goals, and schedules. Initial production is now underway. In a first step toward modernization of its helicopter rescue capability, the U.S. Air Force will begin flying UH-60A Black Hawks in 1983. They will serve the essential needs of the Aerospace Rescue and Recovery Service before the introduction of the HH-60D Nighthawk Rescue Helicopter, another Black Hawk derivative. The HH-60D will contain modifications to permit it to fly alone, at night, or in bad weather, to rescue downed air crews behind enemy lines. Avionics systems integrated into the helicopter will provide the ability to avoid the enemy, fend the aircraft from missile attack when needed, locate the survivor, hover automatically for the pickup and return safely. These systems include terrain following and terrain avoidance radar. The pilot will be able to fly nap of the earth at night or in bad weather, masking the aircraft from detection. FLIR, forward-looking infrared, allowing the pilot to actually see, on a display in the cockpit, what the darkened terrain ahead looks like and take full advantage of that terrain. A navigation system that will permit flight to an exact position over the survivor, and integrated cockpit displays and multi-purpose display systems that will reduce pilot workload while providing a new range of information and a more efficient man-machine interface. Its range will be further enhanced by both internal and jettisonable external auxiliary fuel tanks. The mission can be flown at low levels and at speeds over 140 knots for a total distance of more than 422 miles. The crew will be able to determine the best, safest route to the rescue point. Integrations of advanced avionics and subsystems with the basic Black Hawk airframe will make this possible. The widely diversified mission requirements of these multi-service derivatives demonstrate the tactical flexibility of the Black Hawk. That flexibility is being further enhanced by introduction of the external store support system. The system consists of wing-like external structures mounted on each side of the aircraft, designed to carry fuel tanks and a variety of ordnance. It will be produced in kit form, easily installed or removed by 4 personnel in 40 minutes. The external fuel tank system will accommodate 2 230-gallon tanks in the outboard position and 2 450-gallon tanks inboard. The use of all 4 tanks permits significant extension of endurance and range, making the aircraft self-deployable to a 1,300-mile range with a crew of 3. Using the 2 230-gallon tanks, a 3-man crew and 11 troops can fly 4.8 hours to 635 miles. Other weapons that can be carried include mine dispenser pods, anti-armor Hellfire missiles, 30mm gun pods, electronic countermeasures pods, tow or hot missiles, Stinger air defense missiles, and 55 or 70mm rockets. It also can accommodate scout motorcycles. Various of these elements can be carried in combinations. The system can carry 4 mine dispensers containing 320 mines, capable of covering an area of 215,000 square feet, or 24,000 square yards. 16 Stinger air defense missiles can also be carried for a 2 to 3 hour mission. The prototype external store support system is now in ground and flight test by Sikorsky. U.S. Army operational tests are scheduled for early 1983, with first production deliveries scheduled early in 1984. The Black Hawk offers modern technology developed by Sikorsky. Unprecedented testing resulted in the high reliability demonstrated in the field. Commonality with the U.S. Army inventory also offers the potential for common depot support and training facilities. Black Hawk has now achieved high-rate production stability and maturity. Since the first delivery to the U.S. Army in 1978, over 250 aircraft have been delivered. Production at Sikorsky is currently at the rate of more than 8 aircraft per month. Further strengthening this stability has been the recent award to Sikorsky of a multi-year $950 million procurement contract for production of 294 Black Hawks over the next 3 years. Current planning to increase Black Hawk performance includes an alternate gross weight increase from the present 20,200 to 22,000 pounds, and eventually to 24,300 pounds. Plans are in progress for growth in engine and transmission horsepower. With its firm production base and with the startup of S-860B Seahawk production this year, plus the production of other derivatives in the years ahead, the 860 series will continue to represent the world standard for medium helicopter missions.